Hi, everybody. Welcome to our Visual Studio Toolbox Live. I'm your host, Robert Green, and joining me today is Mark Rendle. Hey, Mark, how are you?
Hi, I'm good, thanks. How you doing?
Great. We are going to talk about gRPC, which is the latest and greatest technology for building services today.
Yes.
Um,
Yeah.
Mark, you was on the show a while ago. We talked about gRPC kind of when it was first talked about, and we did an episode on what is it, how does it work, and we kind of approached it from the angle of, well, I'm familiar with WCF services. What does gRPC look like? And today we thought we would come back and revisit it since it's been a while, but take a much more general viewpoint, which is what does it mean to build and use services built with gRPC? So maybe you've done WCF, maybe you've done Web API. You need to write a service. gRPC is something you should look at.
Yeah.
So let's do a quick overview. What is gRPC? Why was it invented? And why should I think about using it?
So gRPC, it's an RPC framework, a remote procedure call framework, and it grew out of internal things that were being used at Google. So Google very early on were using sort of masses of servers and communicating between them, the whole MapReduce thing, all that sort of thing. And they came up with a very compact and performant serialization protocol, a wire format called Protobuf,
Mm-hmm.
pass data between nodes as quickly as possible. And then they built their own RPC framework called Stubby to create remote procedure call services with Protobuf. And then when HTTP2 came along, it actually did a lot of the stuff that they would. Stubby just ran over TCP sockets. HTTP2, which actually also came out of Google, had a lot of that functionality, multiplexing, message trailers, all the sort of cool stuff that HTTP2 brought. And they said, well, we can just re-implement Stubby on top of HTTP2. And so they did that, and that's what gRPC is.
So does the G stand for Google?
No, it does not. It stands for many things, but it definitely doesn't stand for Google. That's why it's a small
Okay.
g. So it stands for gigantic or great or garrulous or yes, but not never Google. Definitely not.
You name something great, then you're just setting yourself up, I guess.
Yes, but it is pretty great. Um,
Okay, awesome. So let's build and use one. Let's jump
okay,
right into code. How about that?
let's do that. So I've got a solution here. I've got a movies database. It's just in a SQLite.db file. And so I've got my movies data here. This is my movie class. I've got an ID and a title and various properties in it,
Mm-hmm.
uh, and some links and so forth. And I've got a genre of movies. And then here I've got just a regular API using the minimal API form. So we've got our app.mapget movies genre here. And we just go off to the database, include the genres, put in some criteria. We've got paging using a query parameter. And then we're going to turn that into a list and return that back from our API. And so if I just jump to here, and I'm going to do .NET run, see release, get a bunch of warnings because I've got some nullable things going on. And then wonder why that's not showing. The output. And then if I click send here, I get my page 2 out. If I change that to page 10 and click send, I get some different results out here. So this is JSON. Everybody knows JSON. And JSON as a serialization format is is quite wasteful. So on every record that we send back, we've got the field titles are actually being used to structure the data. And so we repeat those field titles over and over again throughout our whole result set, which obviously adds a lot of weight.
Yeah, but it makes it easier during development to see what's going on. But I
It does.
assume
It
in
makes it,
production it's wasted.
yeah. But the other issue that we have with JSON is that, for instance, here where we've got this number, passing a number from a string, it's been optimized. I mean, .NET now does this in the fastest way you can possibly do it, but it is still having to go through this process of reading the characters and working out what that number is as it goes along. And the same thing here where we've got popularity, which is a float, and so on. And so one of the things that gRPC or that Protobuf does is it replaces this way of doing structured data, and it uses a binary format. So I'm going to stop this here. I'm just going to dive straight in and add a movies RPC to this project. So we're going to do add new project. We've got an ASP.NET Core gRPC service. I'm going to call it movies RPC. I'm going to put it into the src directory. I'm going to say next and leave all of that. And that has created a sort of hello world gRPC project here.
So that movies API was just like a general web API?
Yeah, that's just a perfectly ordinary web API.
Got
so
it.
I could actually put my gRPC service directly into my API service. You can run those two things side by side, but that will get very confusing later, so I'm not going to do that.
Okay.
So let's take a look at what we've got here. And the first thing we've got is this protos directory, and in here we've got a greet.proto.
What's a proto?
So a proto is a protobuf interface definition language file. So this is where you say, this is what my messages look like, this is what my service looks like, this is how it works, and you specify all of that up front.
Okay.
So if you think about, if you want to document a HTTP API, you can use Swagger. And the way Swagger tends to work in .NET is that people create their API and then it automatically generates a swagger.json file. With Protobuf, you actually have to write the definition of your API and the objects and things up front.
Okay.
And when you have done that, it generates some model classes and it generates a stub class. And so if we go into greeter service, this greeter.greeter base class has been generated by the Protobuf compiler, and then we can just override the methods on there. So this say hello method here came from this RPC say hello here. And so, and then our hello request is generated from our hello request message here. And this is one of the first sort of big differences with gRPC and Protobuf is because these classes are generated up front, the serialization code for them is also generated up front. So there's no reflection required to create these objects, to send them over the wire and to deserialize them on the other side. All that code is pre-generated. One of the cool things about that is you can actually use native AOT with a gRPC service, and you can actually do that in .NET 7. You can do it in .NET 8 as well, because if you're just using the sort of simple Protobuf compiled code, there's no runtime reflection. There's no code generation happening at runtime, and so this has been compatible with native AOT since .NET 7 continues to work in .NET 8. There are ways in .NET 8 to make a sort of like movies API native compiled, but you have to put in JSON serialization, source generators, and various weird things. Whereas with gRPC, it does just work. So I'm going to add a new item, and I'm going to search for Protobuf in general, aspnetcore, web, Protobuf. No, never mind. I'm going to copy greek.proto, and then I'm going to rename it, and I'm going to call it movies.proto, and I'm going to close greek.proto, and we will delete everything from there down. And we will change the C# namespace here to be moviesrpc.protos, because I like to do that. Okay. So this option C# namespace is just saying all the code that you generate, I want you to put it into this namespace here. There's lots of different options. We might look at another one later on, but that is fundamentally it. So then I've got my movie. This is my entity framework class here. And so I've got a public class movie, and it's got an int ID and a string title. And so I need...
Question, that proto, this is not C# you're writing right now.
This is not C#. This is going to generate C# code.
Okay, so that's why my solution. That's why you talk about namespaces that way.
Yes. So we say when you generate the code, use this namespace for the generated code.
Okay.
So I'm going to start off, I'm going to create a message. So a message is a model, and I'm going to give this message the name movie. And then I want my ID field to be in there, and I need that to be an integer. And so I'm going to use the int32 type. I'm going to call it ID, and I'm going to say equals 1, which is super. So I'm just seeing in the comments, does Mark have any intention to resume streaming / stream more? Yes, I do. I'm going to start streaming fairly soon, and show me converting an ASP.NET MVC project to .NET 8 Blazor with server-side rendering and all that good stuff. So that should be at some point in the next couple of weeks.
Cool.
So yes, so let's talk about what I just did here though. So I've specified a type and a name, and then I've got this equals 1 at the end here, which is weird. So the type, Protobuf has 15 built-in scalar types. We've got int32, int64, string, bool, float, double, and then a bunch of other integer variants. So like there's a uint32 and a uint64, which are unsigned. And then there's an sint32 and an sint64, which are signed, which int32 is also, but it's confusing. There are, yes, 10 of the 15 primitive types are variants of integer, and it's all to do with optimizing how they are serialized. So I'm also going to add in a string title equals 2 here. So these equals things here, that's assigning a number to those fields. So ID is field number 1 and title is field number 2. So when Protobuf serializes these entities into the wire format, it doesn't use the name, it uses this field number as the identifier. And so that's one of the reasons it can keep the serialization format so tight, because it's just using, in some cases, a single byte to say, this is an int32 field number 1.
Got it.
And with string, it will just say, this is a string, it's field number 2, and then it'll have another sort of 4 bytes, I think, for the length of the string. And so then I'm going to also put in string original underscore title equals 3. So if I go over and I look at my movie thing here, we'll see that we've got public string question mark original title. So original title in the data set that I'm using wasn't necessarily there. It's only if it had a different original title. And if I have my movie type here and I say string, it's not actually possible to set that to null. You can set it to an empty string, but you can't set it to null, and you can't set an int32 to null either. So if let's go into the project file. Okay, that's great. It's already added that in there. So we're going to take that out. So we have our movies.proto, and we've got this protobuf include saying protos movies.proto gRPC services server. So that's the thing that's going to tell MS Build to call out to the protobuf compiler and get it to compile this for us. And so let's just going to build that quickly. Build failed. Right, we're going to take greet.proto out. We're going to get rid of greeter service, and we're going to delete that line from there. And then we're going to build that again, rebuild. There we go.
There we go.
Okay, so if I now were to say var movie equals new protos movies rpc.protos.movie, title equals whatever, and original title. Okay, so quick thing about naming. In my proto file here, I've used lowercase with underscores for my names. So the message has a Pascal case name, but my fields have lowercase with underscores. The reason I do that is because the cool thing about gRPC is it's cross-platform. And so I can publish my proto file for people to use to generate clients for their application to use. And they could be using Swift or Kotlin to build a mobile application. Or Flutter. They could be using Python or Go or Rust or C++ or any number of different things. And so we can't say this is the naming convention. So we have to agree that we're going to use a common naming convention regardless of what our language is. And then the compilers for those other languages will turn that into whatever the most sensible thing for that is. And so by using this underscore separated format here, it makes it very easy for it to generate kind of Pascal case or camel case or whatever it is for the other platforms. Okay. So that's come in C#. It turns them into Pascal case as you would expect a C# property to be. And then if we say original title equals null, like so, if we look here, string original title, it's in there. But if I go over to the generated code, so this is hiding in the obj directory. You very rarely need to look at this, but it's useful to demonstrate this point. So we say public string title, but it's actually got this proto preconditions check not null. So I can't put a null into that string. I can put an empty string in there, but I can't put a null in, which is not what I really want to do. So that will actually throw an exception if I were to try and do that at runtime.
Okay.
So what I'm going to do is I'm going to start importing some libraries, and I'm going to import google/protobuf/wrappers.proto. Okay. And that is going to bring in a bunch of more complicated types. And one of them is google.protobuf.string value. Okay. So string value is a nullable wrapper around string.
Okay.
Okay. And so now if I rebuild this again and we go back to program and we look here and you see that it's still string. But if I go to the generated code, it's no longer got that null check in there.
Right.
So yeah, that's something that I like to call out because it is counterintuitive. So let's go back into our movies.proto. I'm just going to grab some other code from here, and we're going to put it in there like that. And we're going to delete that. So I've got a float for my popularity. And then in my model, I've got a release date. And there's no datetime primitive. And so I'm going to do another import line. And I'm going to bring in timestamp.proto. So timestamp is the protobuf equivalent of datetime. And then I can say google.protobuf.timestamp release underscore date equals 6. Okay.
And where is this documented? Is this in the
so if you go to protobuf.io, I think it's protobuf.io. No, it's not. I just searched for protobuf.
Okay.
Protobuf.dev. So yeah, all of this, including the gRPC stuff, is documented on protobuf.dev. It's slightly weird. The runtime framework is called gRPC, but the language, the interface definition language is called protobuf, and the compiler is called protobuf. So
okay, so a couple questions.
Yes.
Option variables. Is it possible to set the option C# namespace, but for Golang, also it is advisable to have a shared repo for these protobuf files?
Yes. So there are options for all the different languages that protobuf supports. And so there would be an option go underscore namespace or something that would allow you to set a similar thing on there. And this option Java underscore has a load of different options. They're different from platform to platform. I don't know what they all are across all the other things. I tend to stick mainly in the .NET.
Okay, and then
so yeah.
Oh, wrong one.
Can you do it the other way around? Create a C# class first, add annotations to it, and have the proto file generated for you? Yes, you can. Mark Gravel, who maintains the protobuf-net library, has expanded that, so you can now essentially write protobuf and gRPC the way we used to write WCF. Should you do it? My personal preference is not to. I like this way round of doing it. I like having the proto file be source controlled along with everything else. And the other thing is that I can put comments in here. And so I can say long description of the movie and things. So I can put comments in the proto file for other people to read so they can get an idea of what's actually going on.
Okay.
But you can do it the other way around if you really want to.
Okay.
So we'll have revenue, runtime, movie status, which doesn't exist. We've got a string value, a float, and a vote count. So in my movie class here, movie status is an enum. And we have none, planned, in production, post-production, released, cancelled, and rumored. And so I'm just going to actually grab this from here and copy that. And I'm going to go back into my movies proto, and I'm going to paste that in here. And then this becomes, essentially this is another definition in my protobuf file, and I'm going to number these as I have to. And then I'm going to upshift these and add, nope, I'm going to add a underscore in there.
So is this another convention that enums are capitalized?
Yes. And the reason they're capitalized is if people are familiar with the way other languages do things, in a lot of languages, there isn't the concept of an enum. So C, C++, there's not the concept of an enum. You have consts, and consts in most languages tend to be named shouty case with underscores. But again, this will generate a C# enum, and it will convert all of this to Pascal case, just as you would expect. So we have our movie status there.
So the question, what shortcut keys did you use to change the case to upper?
Vim.
Vim.
I have Vim mode in Visual Studio. If you want to know what those shortcut keys are, I go into, so if I want to do it on here, I press V to go into visual mode, then I press E to select up to the end of the word, and then I press tilde, so shift and tilde, and that toggles the case of those letters.
And that's an extension? That's not built into Visual Studio, is it?
No, that's VS Vim, which is an extension.
Okay.
Jared Parr maintains it.
Got
And
it.
has done for a long time. I can't use editors if they don't have a Vim mode. I can also now just press U, and it will undo the last change that I did.
Okay.
So yes.
Cool.
So the last thing I want to add into this model, this message type here, is I need a string array for my genres. And so I can't, there isn't an array type in Protobuf. What you have is the repeated keyword. So we say repeated string genres equals 13. And so that will generate a collection type, a collection of string on the movie class. Okay, we got that. And so now we're going to return a list of movies. So let's create our service. So we'll create our service movies. And then within our service, we're going to have an RPC by genre. And that's got to return something. So I can't return repeated movie. So I can only use repeated inside a message definition. So if I want to return a list of movies, I need to wrap it in a message just for that. And we're just going to say repeated movies equals 1. So now I have a movie list, and I can return my movie list. And then in my API, my original API, I use movies genre, and I just use part of the path. But in gRPC, I have to take an argument, and I can only take a single argument. So any arguments I have, I need to wrap up in another message type. And I usually use this naming convention. So by genre request. And then in there, I can say string genre equals 1. And then we can say int page equals 2. And then I can use by genre request as my argument to my movies RPC by genre service. Okay. So the reason why we can only return one thing, and we have to return one thing, and we can only get a single parameter, but we can change what that parameter is. This is one of the ways gRPC tries to help you version your API and modify your API over time. So if the signature of the method changes, then that would be a breaking change. If you add a new parameter and people don't put it on, it means you can't use an older version of the client with a newer version of the service. By making it a specific object that is passed in, we can change the object in the same way that you can add fields or properties or methods to a class in C#, and something that's using an older version of DLL will just not know those methods are there. So it's the same kind of thing in gRPC and Protobuf. That's why we have this restriction of a single parameter and a single response.
Okay.
So now if I go into here and I'm going to add a class and I'm going to call it movies impler, as in implementation.
Yes.
And I'm going to inherit.
That was not a word, by the way, apparently.
No, it's not. Movies RPC dot protos dot. We don't. I need to do a rebuild. Build. Int is not defined. No, it's not. That's a very good point. There we go. And then we'll build that. And then we'll go to our movies impler and we will inherit from movies rpc.protos.movies.moviespace. Okay. So this generated code, it generates a static class movies and then generates an abstract. It's not actually an abstract based class, it is virtual. And so we have this movies base. One of the things I like about it being virtual is that the default implementation, so if I just say override and then choose by genre here, if I don't override this, it's not abstract. So I can compile and run and deploy my application without implementing this. But if somebody tries to call it, they will get an RPC exception where the status code is actually not implemented. So over the service boundary, it effectively throws a not implemented exception, which you can catch on the client side, which I think is pretty cool. So I'm just going to make this async. And we're going to add a reference to our movies data here. And we're going to go to our movies API and program here. So we have got a connection string from configuration, and we add the DB context pool there. So I'm going to grab those lines from my API there. I'm going to come back to here, and I'm going to paste those lines in here and just pull in a couple of namespaces. And so the setup for this is exactly the same as it is for any other kind of ASP.NET Core application. We use the same dependency injection. We use the same services calls and configuration and everything else. Let me just remember to bring in the connection string from here and put that in my app settings. My app settings.json is the same. It is an ASP.NET Core application. It's just a new way of working within that application. And so we have our by genre thing there. And again, I can just do a private read-only movie context, and I can initialize that from my parameter, and I get my dependency injection working there the same as before. And to a certain extent, I can go and I can pull, where's my program here? So I've got my context. Just going to grab those lines there.
So you can just repeat the actual implementation, just grab it from your web API and move it into the gRPC.
Yeah, so I can bring that across here. And I can change this to underscore context. And we need to pull in entity framework core to get that include thing there. And then we just have our request dot page. And so in there, if we go back to our proto file, I've actually made this at int32, but I'm going to change that because it might not be specified. I don't want people to have to specify it. And so I'm going to change that to a google.protobuf int32 value. So now that is a nullable int. And then we can see here, this request dot page is generated as a nullable int. You can just about see that int question mark at the start there.
Okay.
So the generated code is really quite well made, well generated. It's what you would write yourself. And then in here we can just say use request.genre, which is going to pull that off there as well. And so there we have our movies. The thing that we need to do now is we need to change these back in, or we need to turn these movies here, which are movies.data.movie. So they're the entities from Entity Framework. And we need to convert those into the Protobuf movies. And so we are going to create a new movie list equals new movie list. And then in there, we're going to say movies equals, and we get a red squiggles. And you see movie list.movies cannot be assigned to, it is read only. And so movie list has this repeated field of proto movie on there, but it creates it. You can't do anything with it. But what we can do is we can use the object initializer syntax, because that class has an add method which takes an IEnumerable of movie. And so then in here, I can say movies dot select m2 new, let's call that entity, new movies protos.movie. And then we can say ID equals entity.id and original title equals entity original title. And I really love Visual Studio's intelligence here.
Yes.
When I was playing with this earlier on, it was actually without me needing to do anything, just going, do you want to do this one next? And like filling out the entire line for me. So we'll leave that red for the time being, and we'll have tagline equals entity tagline, and title equals entity title, and vote average equals vote average, and vote count equals vote count. And then we will put release date equals entity dot release date, and genres, and this is a repeated field of string. So there we go. And again, we can say entity.genres.select g2g.name. Okay, so here we've got, this is our internal status enum that's being used, and that needs to become the protobuf status. And because they're both backed by integers, we can say protos.movie status, and we can just cast that entity status directly to movie status.
Okay.
Down here, we've got our date, time, release date, and release date over here is timestamp. For some reason that I don't understand, Google have not added implicit conversion to their timestamp type. And so we actually have to use an extension method that google.protobuf adds to datetime to call to timestamp.
Interesting.
And then there is actually another restriction on here. So timestamp, part of the timestamp definition is that it is UTC. So if you have a date that is not UTC and you try to convert it to timestamp, it will throw an exception. And so it doesn't make a huge difference here, but I'm just going to put to universal time in there to get that to work.
Okie dokie.
Okay. And then now I've got my movie list, and it's got all my data inside it. And so I can just return my movie list. Okay. And there we go. So the last thing I need to do is go back into my my program file here, and I will say app.map gRPC service, and it will just pull movies impler in there like that. And that's it. I now have a gRPC service. But what I need to do now is come up with something that can call it. So let's add another new project. I'm just going to add a class library.
Okay.
And I'm going to call it movies dot RPC client. Fine. And then I'm going to grab my protos file here, and I'm going to paste that protos directory into my movies RPC client. And we're going to change this. We're going to say protobuf and include equals, and then we'll put gRPC services equals client into that item there, and that will generate our client code, except it won't do it right away because we need to add some NuGet packages.
So you need the proto file to call a gRPC service?
Yes. So the proto file is essentially in the same way as you would have an OpenAPI.json or a Swagger.json file for a REST API, not REST, but and you can ship that, and it documents how to call your service, and people can use it to generate a client if they want to.
Okay.
With gRPC, you publish your proto file for people to download.
Okay.
And they have to use it. So they have to get the Protobuf compiler for their environment and generate a client. So you can't you can't just hit it from like Postman or from a standard HTTP endpoint. You have to actually generate the client, and so there's overhead there. There is there's a lot more strictness around it, but you get a lot more control over the way that people are calling your service. You ship the proto file, they generate the client, it's pretty much going to work. You're not going to get people slightly misspelling field names or things like that. And the performance that you get, particularly cross-platform, is an additional bonus on top of that. And actually, for us .NET developers, the .NET server implementation of gRPC in ASP.NET Core .NET 8 is pretty much the fastest one out there. there is also Rust, which has a very fast implementation, but we are right up there at the top. So if you want
Cool.
your gRPC service to be fast, write it in .NET
All right.
or Rust. But if you want to write it in Rust, there's a learning curve for you. Yeah. So yeah, okay, I'm going to add in a few few gRPC packages into here. So we're going to add google.protobuf, and we're going to install that. Yep. And we are going to install grpc.net.client. And we're going to install that in there as well. And then we're going to install the one that I always forget, because you might think at this point that if we go and look at the movies RPC project file, it's just referencing grpc.aspnetcore. Okay, if I dig down into not you dependencies, packages, grpc aspnetcore, that references google.protobuf and grpc.tools. But if I go into RPC client and look at grpc.net.client, it doesn't reference either of those things, which is why I've had to bring in google.protobuf for like the timestamp types and the int32 value types and so on. And I'm going to have to add an explicit reference to grpc.tools. And this is the thing that generates your code. So if you think you've done everything right and you've got your proto file and you press build, but it's not generating the client for you, then it's because you forgot this reference.
Okay.
Can you tell how many times I've done that? It's
more than once.
More than once, certainly. Quite often in demos or during talks. Okay, so now we have our movies RPC client. We don't actually need that class one in there. That's entirely pointless. That's just generated code in there. And then I'm going to go down to my movies client console, and I'm going to add a project reference to movies RPC client. Okay. And then let's clear away some of this stuff. So we are going to create a new class, and we're going to call it internal class movies RPC client. And we're going to have a public static async task ilist. Let's move this to its own file. Where did you just go? Right, we're going to have a public static async task ilist movie. And see here, I've got movie from movies rpc.proto. So I've got my movie class here. Get, and we are going to create our new client for this. So totally looking over here at my crib sheet, movies client console. So yeah, so I need to create my new gRPC client. So if I say var client equals new movies dot movies client. Okay, so this is the generated client for our gRPC service, which came from just having that proto file. Okay. But I need to give this a channel. I need to tell it how it can talk to the service. And so I am going to just create a channel. So I'm going to say var channel equals grpc channel dot for address. And we're going to use https://localhost 7151, which is the address. and then we're going to pass that channel. So this creates a kind of underlying HTTP connection, and then we can create a client on top of it. I can actually reuse this channel. I might have half a dozen services all hosted on this same endpoint, this same server. I can create the channel once and reuse it, and actually in factory terms, I can have it managed by the factory, and then I can create multiple clients on top of that channel.
Okay.
So in terms of sockets and everything, that makes you extremely quick. And then I can say var request equals new by genre request. And I'm just going to say genre equals comedy. And then we're going to say var list equals await client dot by genre async, and pass request over there. So it's generated this async method that takes the request and returns movie list. And then I can just return list dot movies. And there we go. So if I now, I'm going to go back over to here, and I'm going to go into my program there. Let's just, so we're going to pull back 100 movies. So I'm going to jump back to my PowerShell here. I'm going to run this, running it in release mode, so there's no cheating going on. And then I'm going to .NET run -c release here as well. And that's not letting that work. Why don't you want to work? Build.
It's calling minimal API client. Is that right?
Yes, so this is calling the minimal API client.
Okay.
So that retrieved 100 movies in 1.8 seconds. And then if I do it again, it goes down to 0.27 seconds.
Okay.
Because that first 1.8 included all the JIT times that only just started the API running. So if I now come down to here, and I'm going to cd into movies RPC, I'm going to say .NET run again. And so now we're running our gRPC service, and we're running on 7205. So I'm going to jump back into here, my movies 7205. And I'm going to change the program here to be movies RPC client. So same, let's put in a timer.stop. It's always good. And then we can go over to here and we can run this again. And it's slightly slower, which probably speaks to how much work the .NET team have been doing. But yes, so it's 0.02 of a second slower.
Okay.
Not entirely sure why that is, but oh, hang on, we can probably make some improvements by turning off logging, but we are running right up against the time.
All right. So let's
take
a couple of questions that have been gathering up. So how can you allow the client to sort on a specific field in a specified order? Is there anything we need to know about that?
If I was going to allow them to do that, I would basically add fields to my request object where they could specify the name of the field that they wanted to sort on, and the order that they wanted to use, so ascending or descending. There's no sort of built-in way of doing sorting across the RPC boundary.
Okay. Would F# have a fast gRPC implementation because it's .NET?
So I'm not sure where we are with being able to generate an F# client for gRPC. I know it's not supported by the core project, but it is potentially there might be an F# generator out there. What you could do using this as an example is you could have this RPC client project in C#, and then you can reference that from F# and use it just as you would any other .NET library.
What about C++?
So gRPC, you can write servers in C++. You can consume gRPC services from C++. You can't do it in raw C for some reason. I'm not sure why. The C++ implementation, though, the .NET implementation, and I suspect this is what triggered the comment, the .NET implementation is faster than the C++ implementation. Don't ask me how. Kestrel is very, very fast, and then we've got some very fast stuff going on top of that. And actually, there's a lot of room in the generated code to make some optimizations, but getting that adopted because of versioning and everything.
Okay. How much of a reduction in payload size, gRPC versus Web API?
It very much depends on the content. So if you've got a lot of text-heavy things, so like blog posts and comments and that sort of things, then the saving isn't going to be as big as the sort of percentage terms. But if you have objects where it's just 10 numeric fields, floats and integers, so in situations like finance and so on, then it's a huge difference because you're removing the field names and you're serializing the numbers using very efficient formats for the numbers. I was working at a place where we were using this in finance, and the difference between JSON, it shaved off about 75% of the total network traffic, simply because it wasn't including quite long names for all the fields. But you're looking sort of, anywhere from 10% up, really.
Okay, all right, I'm going to get to your question next, but I wanted to cover this one. Azure APIM supports this, yes?
APIM?
API management in Azure?
I'm not sure.
Okay.
I know that app services on Linux do support it now. I believe app services on Windows do now as well. There was an issue there because of HTTP2, which IIS doesn't support properly, but now app service is not running on HTTP2. It's actually running on the YARP proxy. And so you can now deploy gRPC services to app services.
All right. One more viewer question, then I have a final question.
Yes, you can have multiple protofiles. So if I was actually building a big, complicated enterprise application, I would put my model classes, so like movie, would go into probably its own class, its own proto-file, and then you can import that. So where I have my movies.proto, I've got import here. You can just say import./movie.proto, and then that can be shared between multiple services. Generally, for the services where I've got my request and response types that are just used by this service, I keep those in the same proto file as the service itself, but have a proto file per service. And then that keeps things nice and tidy.
All right. So my question. So this all makes sense, but it seems like there's a bit of work and it's a little complicated.
Yes.
Coming over from fairly straightforward web API,
Absolutely.
etc. So let's say I want to do this. What are your tips for me figuring out how to make this kind of second nature? How do I make this? How do I? What are tips and tricks for the best way to learn how to do this so it then is
The best way
demystified?
to do this is to go to my website and book me to come to your work and do a 2-day workshop where I go through all of this and much more.
So you're going to come to my house for free and give me a
As-
workshop? Awesome.
no,
We
I'm
have the
going to
best schedule.
charge you a huge amount of
Wow.
money. But if you are
What's
in the
plan
UK or
B?
Europe in particular, then that is an option. And I am duty bound to say it as
Of
an
course.
excuse. That's why I'm not downstairs with my wife. Um,
So let's say my
there's
wife nixes the expense.
there's an
What's
awful
plan
lot of
B?
stuff on learn.microsoft.com
Okay.
about gRPC in .NET specifically. The book that I wrote back in the .NET 3.1 or .NET 5 timeframe, gRPC for WCF developers, it does
Okay.
have a lot of general information in there, and it talks about the protobuf format and
Have
the
the
wrappers,
formats
all
changed
those sorts of things.
dramatically, or is that
No,
still
no, no,
up to
no.
date?
It's very stable. One of the nice things
Okay.
about Protobuf and gRPC is it's very stable. Um, and yeah, um, so those two things are
Okay.
probably the best way of getting in there. I think there are books on gRPC, but I haven't read any of them, so I can't specifically recommend any of them.
So we will. I'm also going to post
And
your
if I
repo.
could,
People
I
should go
just
check that
quickly
out.
1 minute answer one question that wasn't asked,
Okay.
which is where you would use this, because that's kind of a key thing. So you wouldn't necessarily use this. You wouldn't replace an HTTP API with this. The places where gRPC and Protobuf make the most sense is calls between microservices.
Okay.
So where you want a microservice to call another microservice, and you want as little traffic as possible, and you want them to be as fast as possible. The other place where it works really well is mobile applications.
Okay.
If you've got limited bandwidth and you don't want to be sort of hammering your users' data connection when they're on 3G or 4G, then the reduced payload size with gRPC is really quite useful. And so those are a couple of scenarios. What I'm going to do is up to that VSTL gRPC repo, I will post the stuff that I didn't get time to show,
Okay.
which is how to consume this from like a Blazor WASM application, and how from that same service to expose that as an HTTP JSON API without having to write any more code.
We can do a follow-up show if you want to do this again.
Yeah, I mean, absolutely. Let's put one of those in,
All right.
and we can look at doing
Cool.
both those things. That would be awesome.
All right. So in the show notes, we'll add the link to your book, link to some of the stuff on Learn. We'll also repeat this. Really appreciate your coming on. Thanks everybody for sticking around and looking at this. It's a bit of a learning curve, but it totally makes sense, right? There wasn't anything you did that had me overly scratching my head. So
Yeah.
I guess it's just a question of practice and getting used to the syntax and the scaffolding, if you will, the structure of it all.
Yeah. It seems when you first start with it, this whole thing of writing a proto file and generating code seems like a big kind of, why do I have to do this? Eventually you actually get used to it. You're banging them out without thinking about it.
But the implementation is exactly the same. You just basically copied the code from your web API in, and it just ran. So
yeah,
it's not like you got to learn new ways of talking to data or manipulating stuff.
Instead of having a controller, you have a service class, and you implement the methods in there. So yeah.
Awesome.
It's pretty much the same stuff.
All right. Thanks so much, Mark.
Thank you.
And thanks everybody. And we will see you next time on Visual Studio Toolbox.